Okay, two lines. First off, before I do anything, I'm going to put these into vector form. So L1 is R equals, and I need to get to the line, so that's 3, 4, minus 1, plus we have S lots of the distance and direction of the line, 2, minus 1, 1. 2, minus 1, 1. And for L2, it's R equals, get to the line, it's the opposite of the top bits, so 5, 1, 1, plus T lots of 4, 3, 2. That's the first bit. Now I can start answering the questions. Find the equation of the plane pi1, which contains L1 and is parallel to L2, giving your answers in the form r dot n equals things. So that's r, that's the same as ax plus by plus cz equals d, and the ABC here is the n, so I'll find a normal vector to it, and r is a general point on the line xyz. So xyz dot with a normal gives me a value, and that value is d. That's how we normally write it, but that's what it means. So first off, I need to have it's pi1 is it sort of contains L1 and parallel to L2, therefore it's perpendicular to both, therefore cross product the directions. So direction of the first line is 2, minus 1, 1, and cross product that with the direction of the second line, which is 4, 3, 2. Whenever I'm doing cross products, I'm always going to put a negative in the first bit. Right, the first value at the top here is a determinant of not the top. So not 2, 4. So 2 times minus 1 is minus 2, and then take away 3 ones, so that'll be minus 5. Middle one is the determinant of not the middle one. So 4, take away 4 is 0. So minus 0 or plus 0, forget the sign now. And finally, the bottom one is the determinant of not the bottom. So it's 6 minus 4. So that's plus 4, so that's 10. And that is the same as 5 lots of minus 1, 0, 2. And so minus 1, 0, 2 is normal to the plane. So that's what my n is. So I know that r dot n is exactly the same as x, y, z dotted with minus 1, 0, 2, and that equals minus x plus 0y plus 2z. And we're trying to find out when r dot n equals p, so I need to find a value. So I need to sub in point in pi1, and the point I know it's got to be L1, so it's going to be 3, 4, minus 1. So 3, 4, minus 1, I need to sub that in, and that will give me, basically into there, that'll be minus 3 plus nothing plus 2 times minus 1, which equals minus 5. And so we get minus x plus 2z equals minus 5. That's in the sort of Cartesian equation. It wants it in a normal form, so we've got r dot, and the n is minus 1, 0, 2, and that equals minus 5. And so that's done the first part. Part 2, find the equation of plane pi2 which contains L2 and is parallel to L1. Well, again, it's perpendicular to both. Therefore, we get minus x plus 2z equals p, and we need to sub in which can in L2, and that's going to be 511. So sub 511 into this, and that gives us -5 plus 2, and that equals -3. And so therefore pi 2 is r dot -102 equals -3. Part 3, I'm going to do a different colour, just in case this stuff here gets involved with it. And I've got to work out the distance between the two planes. So I'm going to do distance from a point in pi 2 to pi 1. And this is, but I'm going to give pi 1, instead of giving it like, I'm going to give it like it gives it in the formula sheet. And the formula sheet, it doesn't have it ax plus by plus cz equals d. It takes the d over to the other side. And so pi 1 we're going to call -x plus 2z, and it was equals -5, so that'll be plus 5 equals 0. And the distance is the modular sign of -1 times by the 5 plus no y's, so it'll be 0 plus 2 times by 1, and finally plus 5, all over the square root of -1 squared plus 0 squared plus 2 squared, and that equals modulus of -5 plus 2 plus 5 all over square root of 1 plus 4, which is 5, so that equals 2 over root 5, or times top number by root 5, 2 root 5 over 5. And finally, what does that tell me about the relationships between the lines L1 and 2? That it is the shortest distance between L1 and L2, and that's that bit. But just in case you didn't, this formula, that formula is on page 4 of the formula sheet, or the old formula sheet, under vectors, and it's the bottom bit, the perpendicular distance of alpha, beta, gamma from n1 x plus n2 y plus n3 z plus d equals 0, and that's the formula. Just substitute it in there, and that is question 6 done.